The following quantity is a scalar quantity. A. Weight. B. Acceleration. C. Displacement. D. Time. Solution. A scalar quantity is a quantity that has only magnitude and no direction. Of the four choices, only weight is a scalar quantity. So the answer is A. Weight. Opposite in direction, this statement is Newton's. A. First law of motion. B. Second law of motion. C. Third law of motion. D. None of the above. Solution. Newton's third law of motion states that for every action, there is an equal and opposite reaction. So the answer is C. Third law of motion. With initial speed of 14 meters per second, how high ball will go? A. 5 meters. B. 7.4 meters. C. 10 meters. D. 14 meters. Solution. To solve this question, you can use the following kinematic formula, which relates the initial velocity, u, time, t, acceleration, a, and final velocity, v, of an object in motion. $v. We can take the upward direction as positive. Given that the initial speed, u, is 14 meters per second, time, t, is 0, as the ball is just thrown, and acceleration, a, is due to gravity, which is minus 9.8 meters per square second, acting downwards. We need to find the maximum height, v equals 0, reached by the ball. Using the above formula, we get $0 equals 14 to 9.80 Tongan Paangas dollar. $t equals DFRAC 14, 9.8, approximately 1.43, text, s, $. Now, you can use another kinematic formula to find the maximum height. H. $h equals UT plus DFRAC 1, 2, at squared $. $h equals 14 times 1.43 plus DFRAC 1, 2 times minus 9.8 times 1.43 squared $. $h, approximately 10, text, m, $. So the answer is C, 10 meters. Question 4. A 1,500 kilogram sports car is advertised to accelerate from rest to 126 kilometers per hour in 5 seconds. Its engine applies an average force of A. 1.05 times 10 to the 4n. B. 2.3 times 10 to the 4n. C. 3.3 times 10 to the 4n. D. None of these. Solution. To solve this question, you can use the following formula, which relates force, F, mass, m, and acceleration, a, of an object. $F equals ma. We are given that the mass, m, of the car is 1,500 kilograms and it accelerates from rest to a final velocity, v, of 126 km per hour, which is equal to 35 meters per second, in 5 seconds, t. We need to find the average force, F, applied by the engine. First, convert the final velocity from kilometer per hour to meter per second. $v equals 126 times DFRAC 5, 18 equals 35, text, meter per second, $. Now, calculate the acceleration, a, using the following formula. $, equals DFRAC v, u, t, $. Where u is the initial velocity, which is 0 meters per second as the car starts from rest. $, equals DFRAC 35 to 0, 5, equals 7, text, meter per second, squared $. Formula. $F equals 1500 times $7. $F equals 10,500, text, n, $. So the answer is A, 1.05 times 10 to the 4n. A box of mass of 18 kilograms is pulled with constant speed on a level ground with a force, F, at an angle of 20 degrees from the horizontal. If the coefficient of kinetic friction between box and ground is 0.5, the force acting on the mass is A. 49.2 n. B. 59.5 n. C. 69.3 n. D. 79.5 n. Solution. To solve this question, we need to consider the forces acting on the box. 1. Weight, W. This is the downward force due to gravity acting on the box and has a magnitude of W equals mg, where m is the mass of the box, 18 kilograms, and g is the acceleration due to gravity, approximately 9.8 meters per square second. 2. Normal force, N. This is the upward force exerted by the ground on the box, perpendicular to the surface. Since the box is moving at constant speed on a level ground, the normal force is equal to the weight of the box, N equals W. 3. Friction force, F. This is the force opposing the motion of the box due to friction between the box and the ground. The magnitude of the kinetic friction force is given by F equals mu knots, where mu k is the coefficient of kinetic friction, 0.5 in this case, and N is the normal force. 4. Applied force, F. This is the force exerted on the box at an angle of 20 degrees from the horizontal. We need to find the magnitude of this force. Resolving forces. Since the box is moving at y equals half a gram t squared, where y is the initial height, 100 meters. G is the acceleration due to gravity, 9.8 meters per square second. T is the time. Plugging in the values, we get 100 equals 1/2 9.8 t squared. Solving for t, we get t equals sqrt, 100, 1/2 asterisk 9.8, equals 4.52 s. 2. Find the horizontal distance the package travels. Since the plane is flying horizontally at a constant velocity, the horizontal distance the package travels is equal to the product of the horizontal velocity and the time it takes for the package to hit the ground. Horizontal distance equals horizontal velocity time. Horizontal distance equals 40 meters per second asterisk 4.52 s equals 180.8 meters. 3. Answer the questions. Where does the package hit the ground relative to the point of release? The package will hit the ground 180.8 meters horizontally away from the point of release. B. What is the velocity vector of the package when it hits the ground? The velocity vector of the package will have two components. A horizontal component equal to the horizontal velocity of the plane, 40 meters per second. A vertical component equal to the final vertical velocity of the package when it hits the ground. We can find the final vertical velocity using the following kinematic equation. V equals V underscore 0 plus G asterisk T, where V is the final velocity. V underscore 0 is the initial velocity, 0 meters per second, since the package is not moving vertically when it is released. G is the acceleration due to gravity, 9.8 meters per square second. T is the time. Plugging in the values, we get V equals 0 plus 9.8 times 4.52 equals 44.24 meters per second, downward. Therefore, the velocity vector of the package when it hits the ground is 40 meters per second, minus 44.24 meters per second. C. Speed of the package when it hits the ground. The speed of the package is the magnitude of its velocity vector. We can find the magnitude using the Pythagorean theorem. Speed equals sqrt, horizontal underscore component squared plus vertical underscore component squared. Speed equals sqrt, 40 squared plus, minus 44.24, squared, equals 59.4 meters per second. Therefore, the speed of the package when it hits the ground is 59.4 meters per second. A. What is the coefficient of kinetic friction between the box and the surface? B. What is the speed of the box after sliding 1.4 meters along the incline plane? C. In case if the inclined surface is frictionless, what will be the speed of the box after sliding 1.4 meters? A. Finding the coefficient of kinetic friction. We can use the following equation to relate the forces acting on the box. mg sin theta u underscore kmg asterisk cos theta equals ma, where m is the mass of the box, g is the acceleration due to gravity, theta is the angle of inclination, 30 degrees in this case. U underscore k is the coefficient of kinetic friction. A is the acceleration of the box. We are given that the acceleration of the box is g, 3. We can also plug in the values for m and g, and rewrite sin, theta, and cos, theta, using their mathematical definitions. mg, 1/2, u underscore kmg asterisk, sqrt, 3, 2, equals, g, 3, m. Solving for u underscore k, we get, u underscore k equals, 1/2 asterisk sqrt, 3, equals 0.154. Therefore, the coefficient of kinetic friction between the box and the surface is 0.154. B. Finding the speed of the box after sliding 1.4 meters. We can use the following kinematic equation to find the speed of the box after sliding 1.4 meters. V squared equals u squared plus 2as, where v is the final speed, u is the initial speed, 0 meters per second in this case. A is the acceleration, g, 3. S is the distance traveled, 1.4 meters. Plugging in the values, we get v squared equals 0 plus 2, g, 3, 1.4. V equals sqrt, 2 grams, 3, 1.4, equals 2.08 meters per second. Therefore, the speed of the box after sliding 1.4 meters is 2.08 meters per second. C. Finding the speed of the box on a frictionless surface. If the surface is frictionless, then u underscore k equals 0 in the equation we used for part A. Solving for the acceleration, we get A equals g sin, theta, equals g, 1/2, equals g, 2. Now, we can use the same kinematic equation from part B to find the speed of the box. V squared equals u squared plus 2as. V squared equals 0 plus 2, g, 2, 1.4. V equals sqrt, g asterisk 1.4, equals 2.45 meters per second. Therefore, the speed of the box on a frictionless surface after sliding 1.4 meters is 2.45 meters per second.